Okay, so welcome my geometry students to your Chapter 3 review. There will be two videos presented. The first video will cover mainly sections 1 through 4 on the parallel lines and alternate interior angles, that stuff. And then the second video will cover the last half of the chapter with the parallel lines and perpendicular lines in the coordinate plane. Okay, so this is our Chapter 3 review. And this is part 1 of it, okay? So again, there'll be two parts. All right, so I'm going to draw some drawings, and then you need to pause and, excuse me, draw them yourself. Okay, so here is the first drawing. Simple two lines cut by a transversal. We note two things. L is parallel to M, and that the measure of angle 3 is going to be 122 degrees. So on my picture, let's mark those two things. L is parallel to M, and this angle right here, angle 3, is 122 degrees. Okay, so I know those things. T is the transversal. It's always good to identify the transversal, you know, especially if there's more than one transversal in a picture, okay? So T is the transversal. So how do we find all of these other angles? What is the relationship? Okay, so let's start with the measure of angle 1. The measure of angle 1 is going to be 180 minus 122. That's 58 degrees. The reason is angle 1 and angle 3 form a linear pair. Linear pair with angle 3. And we know linear pairs are supplementary. Okay, so there's angle 1. The measure of angle 2 equals, well, 2 and 3 are vertical, so it's going to be the same, 122 degrees. Vertical with angle 3, and we know that vertical angles are congruent, okay? We learned that the vertical angles theorem. Angle 4 is going to be 58 degrees, so we got angle 2. Angle 4 is going to be 58 degrees for a variety of reasons, but the easiest one I think is that it's vertical with angle 1. And again, vertical angles are congruent. So there's angle 4. So those don't really require the four new relationships that we're talking about. But now let's talk about the relationships. I'm going to use all four of these and use one of the four relationships that we've learned. So let's start with the measure of angle 5. I'm going to use that angle 5 is a same side interior angle with angle 3. And I know that same side, so it's the same side interior angle with angle 3. And because lines are parallel, same side interior angles are supplementary. They are the different ones. So the measure of angle 5 is 180 minus 122, which is 58 degrees. The measure of angle 6, I'm going to use the fact that angle 6 is alternate interior with angle 3. Alternate interior angle with angle 3. If lines are parallel, alternate interior angles are congruent. So that means that the measure of angle 6 is the same as the measure of angle 3, 122 degrees. Okay, two more. Let me just slide down my picture just a little bit. The measure of angle 7. So we got 5 and 6. For the angle 7, I'm going to use the fact that angle 7 is an alternate exterior angle with angle 2. Alternate exterior angle with angle 2. 7's here, 2's there. If lines are parallel, which they are, alternate exterior angles are congruent. So the measure of angle 7 is the same as angle 2. Angle 2 is 122, so is angle 7. And then last but certainly not least, the measure of angle 8. I'm going to use the fact that 8 is corresponding with 4. And if lines are parallel, which they are, corresponding angles are congruent. So the measure of angle 8 is the same as the measure of angle 4, 58 degrees. Very key problem that you need to be able to do. And these relationships are so important as well. Okay? All right. Okay, so here is our new problem. Okay, and the question here is find x. Okay? We need to use a theorem that we talked about. Okay? That says if two lines intersect to form one right angle, then there are 4 right angles at this intersection. This is a right angle. That's a right angle. And so is this right here. That's a right angle. So what I could really do is I could take this picture and just focus on what I need to worry about, where the x's are. Here's my right angle. Here's x. Here's 2x. They create this right angle. They're complementary. 2x and x are complementary. Complementary means they add up to 90. X plus 2x equals 90. And here's our equation, and here's what we need to solve. We combine like terms. X and 2x, that's 1x plus 2x is 3x. And we divide by 3. There's x is 30. Notice I don't put a degrees with the x. X is not a degrees. X is a number. If I were to plug this back in, 2 times 30 would be 60 degrees, and this would be 30 degrees, the angle measures. But x is not an angle, it's a number. Okay? So there's using perpendicular lines in that example. Okay, here are the next 2 examples. All right, and I'm doing them together because I want you to see the similarities between them, even though they're not exactly the same. So in number 3, the question is find x. All right. Well, in number 3, they give us the fact that these 2 lines are parallel. So we should know some things. All right, we should know that certain angles have certain relationships. Now, these 2 angles right here, the 14x plus 7 degrees and the 103 degrees, they do not share one of those 4 common, angle pair relationships. They're not same side interior because they're not inside the lines. They're not alternate exterior. They're not alternate interior. They're not corresponding, okay? But can we move one of them? Can we move one of them so that the relationship does hold? Let's take this 103 degree angle. You have many options. Let's take it and let's use the alternate exterior angle. Since the lines are parallel, alternate exterior angles must be congruent. It's an alternate exterior angle with this angle right here. So this angle right here is also 103 degrees. So now look at these 2 angles next to each other. 103 degrees is here, 14x plus 7 is there. They are a linear pair. So now we've created a linear pair. Linear pairs are supplementary. So we used the fact that 103 and this angle are alternate exterior and moved it. And now we're using the fact that they're a linear pair. So 14x plus 7 plus 103 should equal 180. Combine your like terms. 103 and 7 is 110. That equals 180. Subtract 110 from both sides. 14x equals 70. And divide by 14. X equals 5. There's your x value. Okay? So that's question 3. Now, question 4 is different. Question 4 says find x so lines are parallel. Find x so lines are parallel. You don't know that these lines are parallel, but the idea is what would be the x value that would make them parallel? Well, we have to first identify what kind of angles they are. These 2 angles are alternate interior angles. And for lines to be parallel, alternate interior angles must be congruent. Must be congruent. So we must find the x value that makes them congruent. Well, to do that, set them equal to each other. So we have 2x plus 4, that's a 2x plus 4, equals 140, and we solve for x. Subtract 4, 2x equals 136, and divide by 2. X equals, we get 68. And there's your x value. That would make these alternate interior angles congruent, which would make the lines parallel. All right, last problem we'll do is a proof, and then we'll move on to the next video. Okay, so here is the proof that we're going to talk about. So hopefully you pause this and write it down. Okay, so here's our picture. We are given that angle 1 and angle 3 are supplementary. We need to prove that lines L and M are parallel. All right, so we'll create our 2-column proof. Statements, reasons. First statement is always the given. Angle 1 and angle 3 are supplementary. The first step is always the given. All right. Now there's no real way to mark that on a picture, okay? But it's fine. So what can we say from this? Well, if they're supplementary, by definition, the measure of angle 1 plus the measure of angle 3 equals 180 degrees. Okay? That is the definition of supplementary angles. Okay? So now that's kind of like, that's all we can do with that. We're stuck there. But now, we need to look at the picture. We need to look at the picture. What kind of angles are 2 and 3? Angle 2 and angle 3 are a linear pair. We know something called the linear pair postulate. What this says is, if they are a linear pair, then they're supplementary. So we know now that angle 2 and angle 3 are supplementary. Linear pair postulate. All right, linear pair postulate. So what does that mean? Same idea. Use the definition. That means that the measure of angle 2 plus the measure of angle 3 is 180 degrees. By definition. Definition of supplementary angles. By definition. So now look. Look at what you have. Step 2 and step 4. You have 180 and 180. Both of these sums equal 180. What that means is that the sums equal each other. So using a substitution, we can put the sums equal to each other. We can take, say we take 180 out of here and put the measure of angle 2 plus the measure of angle 3 in its place. We take the 180 out here and we put this sum in its place. All right? So our fifth step is that, and I don't know if I have enough room, the measure of angle 1 plus the measure of angle 3 equals the measure of angle 2 plus the measure of angle 3 by a substitution. By a substitution. Okay? Now notice what you have on both sides. We have an angle 3 on both sides. Let's get rid of it. Let's subtract angle 3 on both sides. Let's use the subtraction property. Let's use the subtraction property and subtract the measure of angle 3 on both sides, leaving us with the measure of angle 1 equals the measure of angle 2. All right. Well, now look up here. Look up here at angle 1 and angle 2. What kind of angles are they? Angle 1 and angle 2 are alternate interior. Can we say that they are congruent? Because if they're congruent, then lines are parallel. Well, look, their measures are equal. So guess what the next step is? I'm going to scroll down a little bit. Guess what the next step is? The angle 1 is congruent to angle 2. That is simply the definition of congruence. Going from Definition of congruence, going from equality to congruence. And now we have these two angles congruent. They are alternate interior angles. So by the converse, because we're proving lines parallel, by the converse to the alternate interior angles theorem, we can say that L is parallel to M. Okay? And there's the proof. There's the proof. So these two steps, step 3 and step 4, they came from the picture. You had to get them from the picture. If I go back up, the fact that 2 and 3 are a linear pair, you had to pull that from the picture. And that's prior knowledge. You have to know that. Okay? So thanks for watching, and stay tuned for video 2.